Hello, Pavel is with you. Today I want to proceed simple PCA denoising of a spectrum image and compare two different programs. A few months ago, Gatan released a new version of Gatan microscopy suite, version 3.4, and there is a free plugin for multivariate statistical analysis there. Actually, it is the old plugin of Guillaume Lucas, now commercialized by Gatan. So let's compare this native Gatan MSA program with free basic version of temDM. For the comparison purpose, we will use a simple simulated ILS data cube. There is a variation among three compounds there. Well, the advantage of this example is I know the ground truth because I simulated that. Well, also we need to open the temDM MSA proceed tool. Here we are. And probably a small tool called timer, just because we need to evaluate time required by different programs. In temDM, first of all, we have to prepare a so-called container. That's just an image where all results of MSA analysis will be stored. And you are prompted to choose the energy region. With these two buttons, you can quickly reduce it twice or increase twice. You can also drag manually, but for the moment we need the complete range. Just press confirm. Well, I was not so quick to start timer, but believe me, it takes 1 or 2 seconds. So we have the MSA container prepared. Then we need to extract principal components, and we have to decide how many components we are going to extract. To my experience, systems consist of quite seldom more than 5-8 components. So let's input 10 components here and just press PCA. Start also timer. The first meaningful components are extracted quite quickly, but when we approach the noise components, it goes a bit slower. Well, right now we are extracting the component number 7, and it goes step by step. Well, we have to wait a little bit. I guess we are approaching the end. The last component right now. Up. 39 seconds. Some results of PCA analysis appear. This is loadings, but we can close it without saving. Scatter plot, close as well. Don't worry, all these results are stored in container, so we don't need to take care especially about storing them. We can close it, but probably we will keep open the script plot. From this script plot, we see immediately that there are only 2 components with high variance, and the rest show much lower variance. That's because the rest components are noise. So we decide to use 2 components in reconstruction. Yeah, probably reset timer. And here, confirm, we use 2 components for reconstruction. Just press reconstruct, confirm 2 components, and quite quickly, maybe 2-3 seconds, we have the reconstructed data cube. Don't need scatter plot. Here we also reset the timer. Now let's compare the original data cube and the reconstructed one. First click at the original, then reconstruct it, and choose twin spectrum picker in temDM menu. So some combined display appears. Extend the vertical scale, maybe like that. And you see there are two green markers in both spectrum images. We can move that in one spectrum image, and the second will move synchronously. This way we can inspect the spectrum at all positions, and you might appreciate that everywhere the spectrum, it's a single pixel spectrum, the spectrum is denoised quite dramatically. Okay, to stop twin spectrum picker, just close this display without saving, and you see that both green markers disappear. Well, now open Gatan MSA program, Technique Manager. Here we are, MSA Analysis. Choose the original data cube and press Decompose. So, Gatan didn't ask us how many components we need. That's because by default it takes 100, quite a lot. But it proceeds rather quickly, so it doesn't bother you. I think we're already approaching the end. Okay, only maybe 23, 24 seconds. And some results of the composition appear. We will talk about that later. For the moment, we need actually to see only the scree plot. Here we are. 100 principal components. In fact, we will use only few of them. You might see that the only three first components show great variance, while the rest is just noise with much lower variance. Why now we got three meaningful components, and with temDM it was only two? The reason is Gatan uses the so-called uncentered PCA, while temDM by default uses centered PCA. What does it mean? With centered PCA, the average spectrum is subtracted from the data before PCA, and that reduces the degree of freedom, and you got less principal components. In fact, the difference is not as critical. I can assure you that at the end, the denoising with three components in one case is completely equivalent to denoising with two components in the centered case. Well, by the way, temDM allows you also to proceed uncentered PCA. Just unclick this box. But personally, myself, I always prefer centered PCA because it's more elegant and more compact. Now let's do the reconstruction. I have shifted my window a bit to the right in order you can see more buttons. And we need the button Recombine. Just press it. We will use three components from component number 0 till component number 2 and just press OK. The reconstruction proceeds quite quickly. I think it's about 1 second. And we have the reconstructed data cube. Let's place it here. I think timer we don't need anymore. Let's check how much it was denoised. Click first at the original data cube, then at the Gatan reconstruction, and choose Twin Spectrum Picker. The overlaid display appears. Just rescale it a little bit, and we see that indeed everywhere it was denoised dramatically. Well, now stop Twin Spectrum Picker by closing it, and compare the reconstructions from Gatan and temDM. First click Gatan, then temDM reconstruction, and again twin spectrum pickup. We need to rescale a little bit, and we see that the reconstruction is quite comparable. Well, it seems that temDM denoises a little bit better, but actually the difference is not as dramatic. We can also travel along the dataset and ensure that everywhere temDM and Gatan denoising is quite comparable. Well, stop it without saving. Now let's compare the presentations of the PCA results. Gatan creates a new entity called PCA Analysis, and there are three characteristics there. You can enable or disable the display of each characteristic individually. The script load we have checked already. Now let's look at scores. So, what is that? It's just the map of distribution of a given component. Right now we have the map of the first component, but we can scroll through that using the standard slice tool of digital micrograph. So let's scroll. Here is the map of the second component, third component, and starting component number 4. We have actually the noise distribution. Scroll back. Check loadings. Well, a loading is just a spectral signature of a given component. Right now we see the signature of the first component, and it resembles pretty much the average spectrum of the data. It's very well known that in the case of the uncentered PCA, the first component is dominated by the average spectrum and not very informative. Well, let's scroll. This is the signature of the second component, and it's already quite informative. We see clearly spectral change trends, the signature of the third component, and starting the fourth component, the signatures look pretty much like noise. Let's scroll back. Now about temDM. You have learned that temDM creates a special container. Actually, in case of Gatan, this is also a kind of container. It consists of all results in the very compact form. Well, and that is a clever solution because the alternative could be to create a separate folder with hundreds of files, but then to navigate among these files would be quite boring task. Instead, very compact container where you keep your results. But temDM container and Gatan containers look quite different. In Gatan container, you see immediately what is inside. There are three characteristics. In temDM container, you basically see very little. What you see is just an average image. It's an image averaged over the all energy channels. And to see more, you need a special tool. This is a tool called View Results. And here we have a lot of buttons. Having the container in front, we can press a certain button and get the requested information. For instance, let's request scores from score 1 to score 5. Well, it should be, of course, container in front. Well, scores. Here we have scores. And again, right now it's the score of the first component displayed, but with the slice tool we can scroll. this is the score of the second component. Starting component number 3, scores resemble noise. Other buttons. Button variance. Press variance and you get a script plot. Or you can press kurtosis and get a kurtosis for all components. Kurtosis is just a measure of non-Gaussianity. Say how far your data distribution in a given component, how far it's from Gaussian distribution. Yeah, pretty high kurtosis, negative or positive, it means it is far from Gaussian. And nearly zero kurtosis means it is close to Gaussian. Starting component number 3, we have noise. That's why kurtosis is close to 0. Or one can press get iterations. Then you get a lot of information concerning how exactly components were iterated during the composition. But that is for people who are really interested in details. Let's check loadings. Request loadings of components from first till 5. Here we have it. Actually, the first slice is just an average spectrum, but we are not interested in that. Let's check the spectral signature of the first component. Here we have it. The second component. And starting the component number 3, the spectral signature is just noise. Okay. Here we have an interesting difference between temDM and Gatan. You see that temDM noise loadings resemble rather white noise. Not in the case of Gatan. If you look at Gatan noise loadings, let's scroll to that. It's not white noise. The noise here increases to the left of the display. And the reason for that is in weighting. Both procedures, Gatan and temDM, apply so-called weighting pretreatment before principal component decomposition. That is just rescaling of spectra in order to make the noise over the dataset homogeneous. But in the case of Gatan, it seems that they restore the original spectral scale in loadings. temDM doesn't do that. And to my mind, there is no much sense to restore the scale because loadings are not spectra. They are some abstract things. We can call it spectral signature. And their scale is not as important. In fact, this difference is rather a matter of definitions. Gatan has rights to define their loadings differently. But we have to keep in mind that Gatan loadings, they are not plain PCA vectors, but just something else. The next thing to check is a so-called scatter plot. It's just a joint data distribution between two given principal components. Let's take, for instance, first component and second, and make scatter plot between them. Here we have it. Or we can choose the components of higher number, say third versus second, and plot another scatter plot. Actually, this way we can investigate quite precisely the geometry of data distribution in the multi-dimensional vector space. It can be thought as kind of two-dimensional projections of multi-dimensional vector space, and that is very useful because, to my understanding, our target is not only not only to denoise the data, but also understand its internal correlations. And for that, this scatter plot, they give you incredible insight into, into the business. Unfortunately, Gatan doesn't give you an access to such kind of information. Or to be more precise, I saw the beta versions of Gatan MSA program, and there it was possible to see scatter plots. But for some reasons, later Gatan management decided to disable this option. Well, personally for me, it's a bit pity, but I hope in the future they will redecide and give users access again to this quite useful information. Let's try to resume our findings. First, in terms of PCA denoising, Gatan MSA and temDM MSA perform quite similarly. The denoised results are quite similar, although not identical. Second, the speed of processing. temDM extracts 10 components for 40 seconds and Gatan extracts 100 components for about 20 seconds, more than an order of magnitude faster. And the reason for that is that Gatan uses some variants of SVD algorithm, singular value decomposition, which takes all components at once, and temDM in its basic version uses the Nepal's algorithm, which extracts components sequentially, one after another, and that is more slow. In fact, there is also SVD algorithm in temDM, but only in advanced pay version. Thus, we will not consider that here because this review is only about free software. But actually, the difference is not as critical. The point is, you don't need 100 principal components. The practical STEM spectrum images show extremely seldom, say more than 10 meaningful components. And to my mind, if somebody claims that he has 20 meaningful components, most probably there is something wrong in the data treatment. Well, let me show how many meaningful components I have found in last 10 ILSense and EDX spectrum images I treated. 3, 2, 2, 1, 3, 7, 2, 3, 4, 2. So, we should realize that each extra principal component should be related with some extra latent hidden factor, physical or instrumental, and usually there are not so many. The philosophy of temDM is you should not extract more principal components than you need. Just behave economically. Of course, at the beginning you don't know in advance how many components will be needed. Because of that, temDM offers a flexible incremental way of extracting principal components. You know, we have extracted already 10 components in this data set. Let's request component number 11. Just press PCA. Well, the system realizes that there are already 10 principal components and it asks you whether you want to override them or add new. That's what we are going to do. Now, system does not rewrite the previous components but add another components on top of the previous one. That's a flexible way of doing PCA business. The third point, design of interface. I like very much the Gatan design. Just few buttons, all clear. And also if we look at settings, there are only few parameters and all intuitively clear. In case of temDM, we have more buttons, and that is because PCA denoising is not the main target of temDM MSA. In fact, it's the only first step for preparation to more complicated MSA analysis. Because of that, temDM offers users more detailed look inside the data and uses more buttons. Okay, that's basically was everything I wanted to tell you today. I hope you will continue to follow this series, and I wish you all the best.